Good morning to everyone. I'm PC Ng here from Perkin Elmer. Thank you, i-CRIM, for inviting Perkin Elmer to share the talk on atomic spectroscopy. In fact, for this topic, it's a very long topic. As you know, for atomic spectroscopy, it covers AES, ICP, OES, ICP-MS, sample preparation. Okay, I think without delaying, so we go straight to the point. You all feel free to raise the Q&A later on, or raise the question to i-CRIM. We can answer it later on. Okay. For today, we will cover the application talk on environmental, food, agriculture, pharmaceutical, geochemical, rare element, biological sample material, and selection of atomic spectroscopy. The last session we will be talking about ICP-MS concept, technique, and instrumentation. Okay, just before we start, we'd like to share with you on Perkin Elmer. Perkin Elmer to provide analytical instrument for the laboratory. For example, we got group of inorganic instrument. It has ICP-MS, 4-quarter pole, ICP-MS, 3-quarter pole, ICP-US sample prep, chromatography, GC, GC-MS, LC-MS, MS, and so on. Material characteristic, SPR, NIR, UVVs, thermal analyzer, DSC, TGA, and so on. And the other is hyphenated technique, like HPLC hyphenated with ICP-MS, GC with ICP-MS, GC with FDR, or GC with MS or something like that, FDR with MS as well. Okay. So let's maybe for atomic spectroscopy, we have to look at the sample preparation first before we move into the instrumentation. Let's say, for example, the sample, it can be any form, from food, from biological sample, from pharmaceutical, from raw, solid, powder, waste. And this instrument, it only take in liquid sample, either aqueous or solvent based, not solid sample. Therefore, it need to be converted from any other form into liquid form, organic or aqueous. Okay, so the sample preparation technique, like there are few techniques like combustion, as the sample put in the furnace, ash at high temperature, 500 degree, 450, 500 to ash the sample become ash, then dilute with acid. So the other is open vessel, open digestion like hot plate, and there's one more is closed vessel. It has microwave. So depending on what element you want to do. If you want to do mercury, that toxic element is your concern, like food safety, pharmaceutical, NIOS in clinical sample. If you want to do mercury metal sample prep is validated under microwave. Combustion technique, if you use it, you prepare the sample, mercury loss in sample prep because it's volatile. Same thing as hot plate. Yeah. So, for example, this is the hot plate. For other elements, okay, but not for volatile elements such as mercury and also chloride, in case you want to do chloride. Okay, then the sample prep in Perkin Elmer side, we do have sample preparation block. So it's that similar to the hot block, but it got multi-position, as many as 50 position. So that the position to prepare the sample heat up to 180 degrees, but it's an open digestion. So the other is microwave digester. It got 16 vessel, 8 vessel. If you are going to do, let's say, mercury element, it will be advisable to use microwave digester. It's a closed vessel digestion. Mercury will not be lost during sample prep, and it's you can use the official validated method for mercury sample prep. So this is the microwave. It's a closed vessel. You put in your sample about maybe 0.5 gram, put in the acid, nitric acid, hydrogen peroxide, or HCl. It will reflect in the Teflon vessel. So at heat up to about 180 degrees. After sample cool down at ambient temperature, maybe about 50 over degrees, you can take out and sample prep. So mercury, once it cool down, it will settle down. So mercury will not be lost in the microwave sample prep. So for Perkin Elmer, I would say that the only vendor have sample prep, microwave, hot block, for multi-position, ICP-MS, OES, AES, and so on. Mean that one single vendor for all the analytical techniques, especially come with sample prep, you need to link to instrumentation. Okay, come to atomic spectroscopy. It has these list of instruments like peculiar analyzer, frame AAS, graphite furnace, ICP-OS, ICP-MS, big protocol, and RCP-MS for protocol. So this is the list of the instrument for atomic spectroscopy. Now we take a look. Basically today we are talking about elemental analysis based on the element in periodic table. So ICP-MS can analyze up to about 75 elements in periodic table. AS about 68 elements. Certain element AS cannot be done. Okay. So like now, okay, we start the first topic for today will be environmental application. Yes? Hello? Okay, for you all? Okay. So we start for today, the first topic will environmental application, soil, water, solid waste, and so on. Okay, for the environmental application, we look at, let's say, water, soil, or air. Air monitoring will be on GC, MS, space, ATD, something like that. And for Perkin Elmer atomic spectrum will be on water and soil. Let's say upstream will be surface water, groundwater. Upstream soil will be agriculture, fertilizer for nutrition, plant nutrition. Midstream will be water testing, potable, mean that soil testing. Downstream will be wastewater treatment, plant, drinking water plant, soil, mean that reuse or remediation. So this is the scope for atomic spectroscopy, soil and water. Okay, now we take a look. Malaysia DOE mean that wastewater, influence water, it divide into like maybe standard A and also standard D. As you can see that, let's say maybe we can look into the element. For example, lead. Okay, the lead element is let's say is 0.1. Okay, just one moment on the screen. About lead element is about 0.1 ppm for standard A and 0.5 for this standard B lah. So look at the element lead, tin, and boron. So I highlighted these few elements is okay, as you can see that okay, for this wastewater act, we need to follow like standard method of accepting water and wastewater published by APHA or AWWEA. Or the other is Code of Federal Regulation Title 40, Chapter 1. So this is US EPA. So this is standard method for APHA. Okay. Okay, now we look into it, for example, for lead. For example, lead, we look into it on the standard method. And now versus this is APHA 3111, frame AS. So for frame AS, if you look into the element, it's mercury, arsenic, selenium. This element is not listed under 3111. It's listed under APHA 3114. So it's another method. It's another method. Okay. So okay, then we look into lead element and also these tin. Okay, lead element, even though listed under flame, but look at the range. Start from 1 ppm to 50 ppm. Which is higher than I think stated from the our DOE. So flame even though listed as an element in AS, but based on the detection range, flame AS is not good. Same thing as tin. It starts from 10, whereas for DOE is mean that lower level. Okay. Next is we look into graphite furnace. Okay, graphite furnace, as you can see that lead will be lower. This element, toxic element will be lower. Arsenic will be lower. Either using graphite furnace or using hydride flame AS will be alright. But look at AS, boron element is not listed. It's not listed, and DOE need to do boron as well. If you are doing AS, so boron will fail to do it unless using UV or ICP-OS or ICP-MS. Okay, the other method 3114 is hydride, is basically arsenic, selenium, or mercury. So there are B and C. Okay. And now we look into this, the method for APHA 3120 is ICP-OES method. Okay, so look into this method, that will be very interesting. Like for example, boron is listed under the APHA method. And if you look into it, under the APHA method 3120, tin is not listed in APHA and is listed under our DOE wastewater. However, ICP can perform tin very, very well. So if you want to fully, let's say, fully compliant, APHA 3120, thin element is excluded, but you can use a US EPA 200.7. That is also on water analysis. So either APHA or US EPA 200.7 for this thin element. Same thing as mercury. Look at APHA 3120. Mercury element is not listed. It's not listed. However, it's listed under 200.7 US EPA method. So look into the method. Wow, it has maybe some combination here and there lah. Okay, there's one criteria is very interesting there. Look at arsenic. Based on APHA 3120, arsenic stated detection, estimate detection is 50 ppb. But DOE standard A maximum is 50 ppb. It means that sample must be less than that. But in this APHA method stated must be at least 50 onward. The other 50 is a maximum or below. So that is the official method. And look at these in actual. Now the technology improved very fast. Like Perkin Elmer ICP for information, it can perform 1 ppb for detection in it. ICP can do it definitely, but the method stated 50. This is minimum, but the A is maximum. Same thing as lab as well. Same thing as lab as well. It also have a similar, like it starts from 40 ppb estimate detection. In fact, now the ICP is 1 ppb. So method is method. So depend is whether how you look at this point. Now we look at ICP-MS is APHA 3125. Now whatever just now arsenic listed 50 ppb, but come to ICP-MS it listed 0.025 ppm is 25 ppb. And now the actual it go down to sub PPT level for arsenic. So this method, because as you know, is very old method, down instrument keep improving. So same thing as APHA 3125. You notice that mercury is not listed under APHA 3125. There is no mercury element. But okay, our drinking water air is 1 ppb, wastewater about 5 ppb. ICP-MS can perform 1 ppt, which is 1,000 times lower than mean that they require. In fact, APHA not listed fine. You can use US EPA 200.7 method. It listed there for mercury. Or you can use cold vapor AS like mean that 3112B. So like look at the method is some element, even though it's important, but it's not listed but nevertheless, there are still the method to use ICP-M to analyze mercury. So this is mercury analyzer from Perkin Elmer. That if you want to follow like maybe APHA method, like it is the cold vapor AS 3112 is the method of choice for all sample. APHA listed real. And ICP-MS 3125 may be applied successfully in some cases, even though it's not specified as an analyte in the method. So the method stated, yes, it can be analyzed, but not listed only. So the method also know it very well. So now 3112, this is the method, cold vapor AAS technique. Okay, cold vapor because mercury stable at ambient temperature without any heating. So just apply sodium borohydride and react with hydrogen, produce if react with acid, HCl produce hydrogen. Hydrogen reduce mercury 2+ into mercury atom at ambient temperature. Therefore, it named as cold vapor without any heating. So when transfer to the quartz cell, you have hollow-metal lamp and the detector. Okay, now this is listed on this, the method.
Sorry.
Yes.
Ada orang tidak mute speaker. Nadia Hanata, siapa Nadia Hanata ya?
Okay.
Nadia Hanata, are you listening? Nadia Hanata, please mute your speaker, thank you. Mute your mic. And Sharon. Okay, thank you. You may continue with your own.
Okay, good. Yeah, thank you. Okay. So now we look into it. For example, now it's the summary of this method. Okay, now like frame AS listed APHA 3111. Then five furnace will be 3113, 312 ICP OES, 3125 ICP. Look into it, like certain element, boron, not listed in AA. AA cannot analyze boron, but it's need to do it in the wastewater. Listed under ICP OES or ICP-MS. So from here you can notice. Okay, next is we look into it. Mercury listed under 312 is co-vapor mercury, and also listed under ICP 3125. And ICP OES 3120 not listed, but nevertheless, you can use US EPA 200.7, listed under US EPA 200.7. It got list of 31 elements, including mercury. So next is tin. Tin is listed under frame AS, but however, frame is not sensitive enough to detect tin in the wastewater. So it's either using graphite furnace or ICP-MS. But in actual, this tin element can be done in this ICP, but not listed under APHA 212. But nevertheless, you can use US EPA method. It's listed under US EPA. So it's a combination of US EPA and also APHA 2125 for a full list of elements in the wastewater. Yeah. The other is lead, even though listed under flame, but flame detection is not good enough for this. But as you know, lead is toxic element. So ideally, we will be graphite furnace ICP-MS for toxicity. Let's say for water, wastewater ICP-MS will be good enough, but for food toxicity, ICP-MS will not be good enough. Okay, now these are co-vapor. We know the official method APHA 3112 is co-vapor AS to be run on AS. But however, ICP can do mercury as well, but not listed under the method. It doesn't matter. You can use ICP as a screening or in-house method. If we link hydride to ICP-MS, so we have two nebulizer. One is a hydride nebulizer inlet. The other is a normal element inlet into the ICP. So in this case, you can look into it. ICP means that if we link miramis hydride to ICP, increase the arsenic, mercury, selenium, antimony by a factor of 5 to 10 improvement. So it can go down to below sub ppb level. For drinking water, air is 1 ppb. So just good enough to do it, but even though it's not listed under the official method. So it's your choice. If you want to use as a screening tool on ICP, yes, it can be done, but not listed under the APHA method for mercury. Yeah. So look into it. Let's say now it's 50 ppb. These are without these hydride miramis. This is a signal. 5 ppb with hydride, it improves a lot. Basically, 5 to 10 times improvement on this element. So look at mercury, very stable. So it goes down to sub ppb level. Calibration, you can see 2 ppb very clear. I think for the peak are very stable. So this is just now hydride and mercury. The other common element can be run together. Mean that two inlet, one is a hydride inlet, the other is common element inlet. So for hydride, non-hydride element to be run in single analytical run. So, okay, there is APHA method. Now we take a look. This Federal Code Regulation Title 40 US EPA. It's Clean Water Act. Okay, it's also listed under DOE, like US EPA method. Okay, it's National Pollutant Discharge Elimination System. Now we take a look. Okay, the method here is listed EPA method, APHA method. Okay, aluminum, you can use 200.7 or 3120B. Both also ICP OES method. Okay, antimony also the same. 200.7, 3120, 200% arsenic is also the same. Okay, now cadmium is also the same. 200.7, 3120 cadmium. Now we take a look like chromium. As you know that it listed chromium 6, something like that. But ICP AA is a total chromium. Then UEV to do chromium 6, total minus for you to get chromium 3. So, but anyway, for US EPA and also APHA is doing total chromium. And now come to lead, it's also the same, but interesting part, look at mercury. It is not 200.7, it's using 245.1 or 3112. This US EPA, 245.1, 3112 method for mercury. So these two methods is basically cold vapor AAS. Yeah. So now look at tin. Tin listed under flame AA and graphite furnace, but flame AA detection not good enough, should not be used. It should be graphite and or using 200.7. So you notice that ICP APHA mix up, you can use 200.7. Okay, this zinc is both also can be used. So this is a summary for this further code regulation title 40. So same thing as they put 53, but now it's 1 ppb. This is considered old method. Okay, now this is APA US EPA 245.1. It's cold vapor AAS method for water analysis, mercury in water. Okay, now we take a look. Just some wastewater. Now this is drinking water. Drinking water like mercury, arsenic, lead, like mercury 1 ppb. Lead, arsenic is 10 ppb, very low level. So in this case, so this is drinking water as standard water and also packaged water. These are also Malaysia, mean that standards for water act. This is natural water act, also listed all the elements, basically is natural water. Now this is EU drinking water. It is and compared to Malaysia, approximately the same. I think in fact it's the same. Like lead also 10 ppb, also 1 ppb. This is European Drinking Water Act. Okay, now we take a look. This is 200.7. Just now APHA 3120. 200.7 is listed as metal and non-metal in solution water, wastewater, and solid waste under US EPA 200.7. Okay, so under this US EPA 200.7, it listed element like tin missing out in APHA. Mercury is also listed there. So in this case, you can use 200.7 method to do this element. Okay, now this is Perkin paper that we publish using ICP 200.7. Okay, you can look into it. List of so many elements. This is standard 1, standard 2, standard 3. Those are major elements. Calibration start from high side lah. Okay, this means that it has axial, radial, it's a combination, many elements. So we can see that future water act may be adding in more and more elements because this is list of 31 elements. Okay, this is water, means that check on the recovery is all plus minus within 10%. Okay, it's next is 200.7 is ICP-OEA. We are looking at 200.8. This is ICP-MS. ICP-MS basically is 1,000 times, 1,000 to 10,000 times lower than ICP-OEA. Therefore, this is going for groundwater, surface water, drinking water. So look at this case. If you are using ICP-MS to do drinking water, that is correct method because ICP-MS already include mercury. One single instrument, you can analyze all elements. However, based on APHA 3120 to do drinking water, you look at the air, 3120 is 50 ppb maximum. But in the air, in the air is 50 ppb is maximum, but instrument listed on the detection there is 50, that is minimum. ICP-MS is correct method. Is let's say for the cold case or whatever, ICP-MS is a good correct instrument to do water, but ICP can do really not full set of element. Yeah, let's say full set of element to be validated for drinking water, it will be on ICP-MS. Yeah, but some that probably certain element you are doing in-house, validate your own ICP-MS, there are maybe people doing it for ICP-OES. So this one is listed on ICP-MS. This is Perkin paper 200.8 using ICP-MS. You can look into it that the calibration standard 1, we can start from 0.1 ppb. This is 10 times lower than 1 ppb. And that is correct one because ICP-OES cannot calibrate at 0.1 ppb, cannot. Because anyway, ICP-MS, you want to calibrate mercury at 10 ppt also can 0.01 also achievable by ICP-MS. Very low because the detection for ICP-MS is 1 ppt. So this major element basically very high. So this is element you can look into it. This is a list of US EPA. There are combination of standard mode, reaction mode, collision mode for the list of element in US EPA. Okay, now for this SW, US EPA also is solid waste 846. We are talking about Resource Conservation and Recovery Act, RCRA. Okay, so under this one, for example, toxicity characteristic leaching procedure is US EPA is 1311. It's basically talk about liquid, solid, multiple waste for inorganic. So this one basically refer to this like mercury, cadmium, chromium, lead. This is maybe on the waste. After prepare the sample, run on ICP waste using EPA 6010. 6010. So this is the listed on the element for the ICP OES. So okay, for this US EPA, it also listed on the method from here for the sample preparation. You can look into it like there are so many methods, acid digestion, many acid digestion for ICP-OES extraction. And if you want to do mercury, it listed 3051 and 3052. These two methods, microwave assisted for acid digestion is validated for mercury. 3051 is leaching without applying hydrofluoric acid. 3052, if you are doing sample sediment contain silica, you need to add in HF. You have to use 3052 is total digestion. 3051 is leaching. Whatever can come up is not total digestion. So other than this method, the rest all method, as long as you are not analyzing mercury, any other method will be fine. So, and after sample prep on the method, then to be run on two instruments, 6010 ICP-OES, 6020 ICP-MS. As you know that ICP-MS 1,000 to 10,000 lower than ICP-OES. Because ICP-MS is expensive. Not all the lab mean that can have ICP-MS. Therefore, it also gives the option. Okay, so like 6010, after sample prep, it put mercury here. You can analyze, but there is a note. Mercury is not typical by this method. It's not recommended for low-level quantitative. It's stated mercury is not low for ICP-OES. So you can use as a screening tool. So listed about 31 elements, row 1, row 2, and this all thing. So this is US EPA 6010 on Perkin Elmer ICP-OES that we are running. We are also running on this element with internal standard. So then we are running plus minus within, they say about 4-hour run is within 5% for the, the recovery plus minus, okay? So 6010 ICP-MS, 6020 is ICP-MS mass spec. So it put the work. You can go down to low level, sub PPB level, it's PPT level, apply to groundwater aqueous sample. So ICP-MS, you can use APH 2125 or 6020 method. Yeah. So mercury is also listed. So EPA listed mercury in the method. APH not listed. You have to use different parameter, different instrument. Sometimes doesn't matter. You can the accreditor under US EPA method is also okay. This is a paper from Perkin Elmer. Is US EPA. These are 6020. Okay, so you look into it, mercury element. Okay, it only put two cross here. You want to prepare mercury, only two methods been recognized is microwave. Other sample prep method is not recognized by these SW846 method. So mercury is very critical. Now, after we look into it, now we look into Marine Water Act, Malaysia Marine Water Act. Look into it. Mercury 0.04 ppm is ppb is 40 ppt. Look into it. It's even lower than drinking water. Our drinking water is 1 ppb for us to drink, but marine water is 40 ppt. That is very interesting. So okay, apart from here, other element is also very low. All are basically in the ppb level. But look into it. marine water is very different because it's a complex sample. All sorts of sample metrics are there. High sodium, high calcium, high potassium, high magnesium. They are in percent.